Hello everyone, welcome to the second part of our video, which is about Coulomb's law. This time, we will talk and focus more on the computation using Coulomb's law equation. And at the end of this video, you are expected to compute the electrostatic force between two charged bodies separated by a certain distance. Let's review first the mathematical equation of Coulomb's law before proceeding to the sample computations. Coulomb force is mathematically expressed as F equals to K times by the product of Q1 and Q2 divided by the R squared or D squared, where F is the force, which has a unit of Newton with the symbol of N, while the K is a Coulomb constant with a value of 8.99, or simply as 9 times 10 raised to 9 Newton per meter square per Coulomb square. Remember that this value is constant, so it will still have the same value no matter what. The Q is the charge on object, and the unit of charge is Coulomb with the symbol of C. The Q1 is charge for object 1, while the Q2 is the charge for object 2. While the R or the D is the distance between two objects, the Q1 and Q2, and it has a unit of meter with the symbol of M. Now that you are already familiar with the equation of Coulomb's law or Coulomb force, let's now proceed to given examples. Example number 1. Object 1 has an electric charge of 75 Coulomb, while object 2 has an electric charge of 90 Coulomb. So what is the magnitude of force if the distance between two objects is 0.005 meters? So the first thing that we need to do here is to identify the given. So based in our example, the givens are charge for object 1 or Q1, which is equals to 75 Coulomb, and the charge for object 2 or the Q2 is 90 Coulomb, and the distance between these two objects, which is represented by the symbol R, is 0.005 meter. Then, what we need to find here is the magnitude of force between these two charges. So to find the magnitude of force between these two charges, we need to use the formula or equation of Coulomb force, which is force equals to Coulomb constant multiplied by the product of charges divided by the square of the distance. So let's substitute the given to the formula. So we have K, the value of K, which is constant, equals to 8.99, or simply as 9 times 10 raised to 9 Newton per meter square per Coulomb square. Then our Q1 is 75 Coulomb and our Q2 is 90 Coulomb. Then divide it to the square of our distance, which is 0.005 meters. So in here, the first thing that we need to do is to multiply the two charges, the Q1 and the Q2. So if we're going to multiply that, the answer will be 6,750 Coulomb square. And then the next thing that we need to do is to get the square of our distance, which is 0.005 meter. So if we're going to square that, the answer will be 0.000025 meters square. And then cancel the same unit, which are the square Coulomb. And then the next thing that we need to do here is to multiply the value of Coulomb constant, which is 8.99, or simply as 9 times 10 raised to 9th power Newton per meter square, to the product of our charges, which is 6,750. then the answer will be 6.06825 times 10 raised to 13th power Newton per meter square. Then divide the answer to the square of the distance, which is 0.000025 meters square. And then, if we're going to divide that, the answer will be 2.4273 times 10 raised to 18th Newton, because we already canceled the same unit, which is the meter square. So if we're going to round it off, it will be 2.43 times 10 raised to 18th Newton. So this is the value of the magnitude of force between the two charges in our first example. Example number 2. Metal 1 has an electric charge of 35 coulomb, while metal 2 has an electric charge of 70 coulomb. What is the magnitude of force if the distance between two objects is 2 meters? So let's follow the procedure we did in example number 1 in computing the example number 2. So let's find first the given. So in our example number 2, the givens are our Q1 is 35 coulomb, our Q2 is 70 coulomb, and the distance between these two charges, which is represented by R, is 2 meters. Then what we need to find here is the magnitude of force between these two metals. So just like what we did in our first example, since what we need to find here is the magnitude of force, we are going to use the formula that we used a while ago. Then substitute the given to this formula. So we have K, which is 8.99 or 9 times 10 raised to 9 power Newton per meter square per coulomb square. So as you can see, the value of our Coulomb constant is still the same since it is constant. Then our Q1 is 35 Coulomb and our Q2 is 70 Coulomb. Then our distance, which is represented by R, is 2 meters. So again, the first thing that we need to do in computing the Coulomb force is to get the product of the two charges. So we have here 35 coulombs times 70 coulombs, that is 2,450 coulomb square. And then get the square of our distance, which is 2 meters. So that will be equal to 4 meters square. And then multiply the value of Coulomb constant, which is 8.99, or simply as 9 times 10 raised to 9 Newton per meter square per Coulomb square to the product of our charges. And then if we're going to do that, the answer is 2.20255 times 10 raised to 13th power Newton per meter square. We already eliminated the Coulomb square as the unit because we canceled it since they are the same unit. Then divide the answer to the square of our distance, which is 4 meters square. So if we divide that, the answer will be 5.506375 times 10 raised to 12 Newton, since we canceled the unit meter square. Then if we're going to round it off, the answer will be 5.51 times 10 raised to 12 Newton. So that is the magnitude of force between the two metals in our example number 2. So now, for us to find the charges, the Q1 and Q2, and the distance between them, we need to derive formulas from the given formula or equation of Coulomb force, which is force equals to Coulomb constant times by the product of object charge 1 and 2 and divide it to the square of distance. So here, the first thing that we need to do is to cross multiply this equation. And if we're going to do that, the answer will be force times by the square of distance equals to Coulomb constant times by the product of Q1 and Q2. And then, simply divide both sides by what is need to be cancelled and write the remaining variables. For example, if we need to find the Q1, simply divide both sides by Coulomb constant times Q2, then cancel it. Then, write the remaining variables, which are Q1 equals to force times by the square of distance divided by Coulomb constant times by the charge of the object 2 or the Q2. Then let's do the same thing in deriving the formula that we need to use in finding the Q2. So let's use the product of cross multiply of the Coulomb equation, which is F times by the square of distance equals to Coulomb constant multiplied by the product of Q1 and Q2. Then again, let's divide both sides to what is need to be cancelled. Since this time, what we need to find is the Q2, so what we need to do is to divide both sides by the variable of Coulomb constant multiply by the Q1 and then cancel them. Then the remaining variables will be Q2 equals to force times by the square of distance divided by the Coulomb constant multiplied by the Q1. Lastly, to find the value of R or the distance between two charges, we will do the same procedure. So we will use again the product of cross multiply of the equation, which is F R square equals to K multiplied by Q1 and Q2. Then divide both sides with what we need to be cancelled. So in here, since what we need to cancel is the variable of force, because what we need to find is the r square or the distance, so we need to divide both sides by the variable of force, then cancel it. Then the answer will be r square equals to Coulomb constant multiply by Q1 and Q2 divide by the Coulomb force. So since our first variable, which is referring to what we need to find, has a square, we will square both sides for us to cancel it. Then, the formula in finding the distance between two charges is distance equals to square of Coulomb constant multiplied by the product of two charges, divide it to the electric force. So these three are the formulas that we need to use in finding the Q1 or charge of first object, Q2 or the charge of second object, and R or the the distance between the two charges. So therefore, by means of these equations, we can say that Coulomb's law signifies the inverse square dependence of electric force. And it helped us to determine the forces acting between the charged bodies. So this is the end of our discussions. I hope that you learned all the concepts from the video 1 and the mathematical expressions of this video. And if you didn't watch the first part of this video, please watch it for the betterment of understanding of this lesson.